Hello, hello. So, now that everybody's here, you see, this is everything that's left from last time. Everything that's not this is gonna be completely different. Okay? So let's get this out of the way first. Next, we have some prototypes. So, the decision has been made that we are going McPherson. We are ditching the double wishbone setup and pull rod because realistically, it's not gonna work. I thought long and hard about how, how to make the springs in order for this to survive any jumps or any kind of driving. Basically, the pull rod is not gonna survive anything. It's not gonna react well. It's gonna be crap. Plus, this is gonna be more true to the original. It's gonna be more compact, and subsequently, it's gonna be much lighter because you see, for what we had before, we used up a lot of material for nothing. With the with the McPherson, this is the upper spring mount, and that's it. We mount the spring, and that's it. Nothing less, nothing more. That is it. It's not that simple, of course. You see, what's missing is the lower portion. So we are not done here. So basically, we need to engineer. You see, this is all gonna be perfectly fine. Even I think we are even gonna get bigger steering angles from the way I see it. It's amazing, actually. However, now we need to do the lower mounts here, and me and Leon have had me and Ben had over the past 2 days we had quite a discussion. No, the shock absorber is, we are gonna make it fit. See, if nothing else, the car is gonna have a power bulge here. So I don't give a shit. We are going with this no matter what. If it's too high, it's gonna have a slight power bulge. Or in the extreme case, this thing is gonna stick out. Who cares? Nobody is gonna reprimand me for this sticking out, and I can live with it if the car performs. So I'm really not concerned, And in the rear, ish. It's the multi-link suspension when at full compression was almost as tall as this. So and the plus side here, of course, is that we have even more. With this, we have even more articulation. So basically, the oh, come on, what's the English word? Oh, come on, what's wrong with my brain? I can't remember. Yeah, exactly. Performance first. So what we have to do now is do the lower links, and here lies the well, problem. Let me explain. We are gonna build. We have here two versions, and we're gonna build a third one as well that Ben has engineered, and we are suspension travel. Thank you. And we're gonna build a third one, and then we're gonna examine, what the options are. Um, so yeah, that's that's the theme of today's stream. Um, Basically, we are scrapping everything that we did in the past few streams, and we're restarting with the McPherson, because I think this is really, that's how we should do it, and that's how I wanted to do it, but I didn't know how really, But now one of those solutions is gonna be, it it has to be right. So let's go through those two, and there's a third option, kinda ish, with this, and let's see what the pros and cons are, and where, where we can go. Okay, first, what I came up with after Ben showed me some of his ideas. Um, Let me get you closer. So we have this thing. Ideally, we would have this connector be a come on, where is it? We would have it be a this, but it has to have a 2-stud axle, but this sadly doesn't exist in Lego. So I have to use this. I don't like it, but I don't see an option otherwise. Let me explain why. So we could stop moving. We could go with, with the simple solution and mount this here. Come on. Mount this here, and we would have exactly the same geometry as we had before, even stronger, because this is better. But and here is the problem. The thing is that this thing here then moves, and quite severely. So basically we have this, and this is absolutely unacceptable. It's a deal breaker basically. So that's no go. So we have to have this, which enables us to, well, prevent this from flexing, or from pivoting. So sadly, I wish there was a piece that we could use here instead of this, but there isn't. This thing here is not ideal either, but we can live with it. It's, it's in the same plane as this guy here, but we where is the 9 link? Here it is. But we can make it work, depending on the angle, we can make it work. And this here, when we are turning, it kinda is just on the cusp, where if we had a millimeter more here, the CV joint would start binding, So this is kinda on the edge, but we are going to move this guy here half a stud further out anyway, because we're gonna redesign this a little bit. And with the redesign here, we could, potentially do something to this, but I doubt it. But that doesn't matter, I think Lego would be better off if they invested more thought into creating new parts, because they clearly didn't invest enough thought into creating those parts. These parts here have stupid limitations that basically, if very, they have like they are thick here on certain parts where they should be thick, uh, and if I would shave this off, it would not affect the structural integrity of the part at all. It's just there for whatever reason. And these edges here prevent us from mounting certain parts that we otherwise could, which is a bummer. And limits, I mean, if I was allowed to modify parts, I would, and then things would fit. But that's not allowed, so we have to work with the limitations. And the parts are stupidly engineered. If this was an LP power part, this would never be engineered like this. The thickness here. Why would you have this thickness here? Why would you not make this just, come on, focus. Oh, clearly we don't need the background. Okay, so why on earth would you have this part here? You can have this supported down there, and I would prefer this to be the thickness of a lift arm in the entirety, so that I can fit parts here next to it. But I can't. Stupid design. This part would be useful if this would be the case, but it's not. I mean, small things that would make this part so much more useful, even though the CV joint is garbage. We and this is not the only part like this. There's several. Yeah, I don't understand it, but that's how it is. And these springs, okay, if for cars in the size of the Sierra, these springs are perfectly fine. For the cars like the Audi, if those were 2 studs shorter, wouldn't hurt. And they could be 2 studs shorter without problem. We would need just you see here down below, this is 1 stud here. If this wasn't here, nobody would care. And if we had 1 stud less travel, we would have the spring be essentially 2 studs shorter, and that would be perfectly fine. For smaller models like this, you could have a McPherson that would be perfectly fit for the car. And of course, if this part here would be properly engineered, we would be able to do everything. But we can. So next proposal. So Ben then engineered something else based on this, I guess, and we have this here. So this thing, if we compare, it's of course turned 90 degrees. The part itself is versatile, so no real problem here. But of course it has the limitations that we spoke before, and we simply cannot mount a proper link here because this part here is too thick. CV joint and 2 pulley wheels with pins sticking. What? I don't understand, but I cannot design my own part. I mean, I could 3D print it, but I would never use this CV joint if I design my own part. I would design everything new. And if we design if we would design a hub like this, um, the CV would be a lot different. And if I must have a hub where which limits me from installing parts close to it, I would want this CV joint to be like in the 8880 supercar. Definitely not, maybe a little bit smaller, but with articulation as large as that. So yeah, that's my wish. So yes, I have built a transverse gearbox before, but you know it's a long time ago, and the CV joint here is exactly why I haven't ever tried to build front wheel drive vehicles, because the damn Lego CV joints, they are so limiting that I couldn't bring myself to do it, because yeah, I mean in this small scale I guess they will work, but in a larger scale, for example like a Sierra, I don't know. Anyway, uh Rosangela, hey, welcome to the stream. So let's get back to this. So this is another proposal, of course, because of the limitations that we spoke before. This thing here, of course, is already stressed. You see how it bulges out because there's not enough room. Come on, go. There's not enough room for the ball joint here, and you know it's pressing down slightly. So not ideal. We could put a pin here, so a ball pin here, like here. But we have another problem then. There's not enough articulation here possible for the steering to happen. So that's kind of a bummer. That's not ideal. And the problem here is, of course, that the caster angle, so the caster angle goes from this ball joint down there, and it has to go through the CV. So if you imagine here, I'm gonna try to approximate it. There, that has to be the caster angle. You know, whatever this is, it has to go through the CV, and the lower virtual pivot point has to be, of course, on this axis, going through the ball joint and this, and then the virtual pivot is somewhere here. Yeah, Ben, and get disqualified on the spot, and then you know, what should I do then? Yeah, that's not very smart. So I like the things that are used here in the construction of this, but I can't use it, sadly, because this is just too restricting. I would like to use it, but I can't. Ideally, I would have this ball joint be here somehow. I don't know, but sadly we can't use this. We will probably use this. It's also not ideal, but with some modifications to bring it so that we basically have the spring in the same position as it is here, we can make it work. So basically, you know, the main thing with the McPherson, come on, stop moving, is that it really, you know, it really is gonna take the beating that it has to. You know, it's the only way we can have a proper suspension here that, you know, that's gonna take it. There's really not much that can break here. to be fair. Whichever version we use, both are, both versions are resilient. And we are going to incorporate some good things from this into this. And then we're gonna design these mounting points on the body. So basically, we have enough clearance here, and we're gonna move this thing here half a stud further down there, so it's in the same position as this. And then these two, you see, these two are gonna have even more clearance, and it's gonna be fine. So yeah, and this guy here shouldn't be a problem because of the angle here. This should be perfectly fine. I don't know. Yeah, this, Christian, this is for the Audi. Just a second. Okay. I just thought it started raining outside, but no, it didn't. So let's see what we can do here. Of course, we're gonna use another one and keep this as a template, and this one as a role model, so to speak. I'm just gonna change the springs here. Okay, there. So in an ideal world, we would remove this here. Problem is that we do need something to hold this here up. So no matter what, something needs to be here. If we position this like this, my problem is that then this is gonna be able to swing like this. If I have it like this, then it's of course fixed, and that's okay. And this, I don't know. I think this should be okay. We should get, since we are gonna have the pivot is not gonna be around this, but it's gonna be more complex. I think, I don't know. We have to build it, but I think we should be fine with this. We only have to move this one step further down. So we have to basically redesign this holder. Get rid of this, so we can have the support here. This support, which basically makes sure that this stays in place. So this support is not very good. This support is much better. So we're gonna take this as a role model, kind of. So let's see, what can we do? We need, of course, we don't want to use the triangular part here because it takes up too much room. It's 3 studs thick. It would solve the problem here, but we can't use it because it's too thick. So what can we use? That's the tricky question. It has to have an axle here, there. Let me think. Let me think. Basically, we need a structure like this. I don't know. I'm gonna just put some lift here, just completely unrelated. So we need a part like this. If we had this part, that would be ideal. Okay. Ben is surprising us again. But yeah, okay. So a few things in this picture are no go, but a few things are very good. Yeah. This is actually pretty good. Yeah. Okay. So one idea that Ben has made. And of course I have those parts here. Another one. So what we are gonna do here. There. And then we are gonna use my favorite part, of course, again. Oh, come on. We have, of course, this and this. This. There. Now we need 1, 2, 3, 4. Okay. Now we need a 3 stud. Where is it? Okay. A 3 stud. Come on. Okay. I think a 4 stud. So 3 stud. There. With this guy. And then we use exactly what we used here, which is this here. Interesting choice. Let's see. 1, 2, 3, 4. Come on. Don't I have a... I do. Okay. So this should be a 4 stud. this, and then we have from the other side this. Um, okay, I'm already attempting over engineering. Now we have this here, like this, there, and this, this, and now we have, oh, it's a fiber. It's a fiber. But wait, I think it's a fiber. We are going to use a 6 here. I think even the 6 is gonna be, it's gonna be too long. Wait. No, a 6 is gonna be just right. Just what we need. So this is gonna be slightly problematic, but just at the moment for proof of concept, let's not worry about it. So this is actually pretty good. We have all of the space here. This is very sturdy. All things considered, this is pretty good. The angles, these two, of course, ideally this would be half a stud further up, but it is what it is. We can't have this pivoting around, because then everything here just moves, as I shown before. So I can just remove this, and you can see this. We can't have this. This is gonna be a huge problem. You see, every time we even it skews even when some load is applied. We get this, so that's no go. We have to have this supported, and now it's fine. So sadly, we have to have this. If this was a axle hole, that would be different, but it isn't. Thanks, Lego, and your double wishbone template. So useless. Yes, okay. So next issue is, of course, providing enough space for this. I don't know if this is even an issue, because I don't know if this, maybe this is gonna be enough. Maybe this isn't even gonna be an issue, and if it is, we're gonna deal with it later. So I will assume at this point that this kind of articulation here at this point is enough. I mean, we'll see. If it isn't, we can always you know, redesign this a little bit, I guess, or move this just up, one step up, and it'll be fine. Yeah, we can move this one step up, and it's gonna be perfectly fine. I even think we should move this one step up anyway. Like this, you know. And now it's gonna be fine. So we have these two options, and then we're gonna choose which one is the best. Hello. We canceled the push rod for a few reasons. First, it was my main concern is was the springs. Mounting springs in that push rod that would be capable of withstanding all the stresses that the car would be facing was never going to happen, because we are so tight on room that in the front we don't have room for a gearbox and suspension, a suspension that would actually work. You see, because the hard springs that we would actually have to use, so these here are very hard, and if you support them on the sides, they actually don't spring, they just bend, and when they bend, they don't provide any articulation. So and if we wanted to go this route, it's never gonna happen. But the McPherson is small, it's there, and it reacts, you know. I cannot stress enough how good this is, you know. This is excellent, and it's steering and everything at the same time. I mean, and it saves weight, it removes complexity from everything. This is just brilliant. I mean, the guy who invented McPherson is just a genius. It's not in terms of geometry, it's not the ideal suspension for every application, or for, you know, but it's, you know, for most applications it's perfect, and that's why it's being used in the car industry since forever, because it's that good. BMW used it, all major manufacturers use it in most of their cars, you know. So I think it's good enough for us here. Rally cars all use McPherson suspension, you know. The Audi, the original car that we're building, used it, so it can't be bad. And yeah, we're gonna use it because it's lighter. Everything is gonna be lighter, less complex. We're gonna have more space, and, you know, all of that. Yeah, so this here, let's see what we can do. So we have 2 points already. We have the upper point defined, and we have this guy here defined. Of course, the steering is gonna be at the same angle and the same length as this guy here, naturally. So what this means is that the steering rack is gonna be a half a stud affair because of this, because it has to have the same angle. But this is not the end of the world, I guess, you know. Of course, we have to take care of the caster, which might not be a, you know, gigantic problem. Of course, the caster changes when we compress this thing, but here we have to actually, you know, the caster here is not okay. I don't know why it was better in a suspension that I did before. Probably it was this thing here. If this it would be half a stud, then the caster would be fine. So we need to move the upper suspension joint a little bit inwards. Come on. Will you please jump in? Okay, thank you. Okay, so we have the room to do this, no problem. And of course, it's gonna be, if you guessed, it's gonna be a half a stud affair. You guessed right. So we need to move this half a stud inwards. And I'm wondering if we should use this guy here instead of for the support, because this would make everything much easier. So we can use this guy here for this, yes, or no, wait. Wait. Ah, okay. We're gonna do it like this. For now. Ah, well, okay. What the fuck is wrong with me? We went half a stud too far in. Okay, it has to be like this. Yeah, okay. It has to be like this, which means that if we do this symmetrical, and we use 7 stud lift arms here. For now, of course. Because what I'm trying to do now is just testing. Weld. What do you mean by weld? Okay, first issue here. But first I want to see what the situation here is. Come on. Okay. So let's see. Okay, the caster now is fine. Yeah, the caster is fine. The camber is fine. So we have a slight, is it negative or positive caster? I don't know. Here, and then when the suspension is compressed, we gain camber and it's fine. Okay. So this is okay. This here is not okay because we cannot steer. So yeah, and we have to move this We have to move this one stud further back anyway. So let's do this. And then it should be fine. Fuse two parts into one. Can you post a picture on Discord? That would be interesting to see. No, we are not ditching the virtual pivot. Come on. And the reason why we're not ditching the virtual pivot is because the virtual pivot provides us with not inconsiderable mechanical advantage, because the forces on the tires and the suspension are gonna be quite big when the car is gonna drive and jump and everything. And the closer you have the pivot inside, and this is gonna be quite a big difference. The bigger the forces on the suspension and everything, the closer we have the pivot to the center of the wheel, the less the forces here are giving us a headache. And I absolutely do not want the forces here to overwhelm us. Okay, I have done nothing here. I need to get these two studs put it back. The virtual pivot has to be there. I mean, the temptation, of course, is there. Just slap a arm down on that central hub, and you're done. But I don't want this. It's ugly. It's not okay. It's mechanically not proper. Yes. Oh yes. Okay. Now this is cool. This is cool. Yes. Okay. So what we have to do now is we have to make a mounting point for this here in the back somewhere, preferably like this. Let me see. It's gonna be somewhere here. course, we're gonna do a prototype first. But this looks okay. See? Yeah. See? Just where it hits the A-arm, it wouldn't go any farther anyway because of the CV joint. So that's okay. So when it hits the link here, that's it. That limits the articulation, and it limits how far the CV can rotate, and then it doesn't bind either, because if we allow it to rotate any further, then it binds already. So that's cool. We just have to determine where the point here is. Somewhere here. Let's see. Approximately. Yeah, it could be here. You know what? It could be pretty much the same as it was before in the old setup, just one stud further inwards. So I will build a prototype for it, and we'll see if it's okay or if it's not okay. We'll see, and then we can discuss if its implications. I actually wanted to do something like this already today, but was interrupted. Oh, I can use this. Okay, I can use this as a helper. So basically, we'll see. We'll see. I want to test it. Maybe it will. Maybe it won't. Sometimes intuition is right. Sometimes it's not. I don't know what to tell you. I'm gonna test it, and we're gonna see. Right now I'm building the front suspension, because the front suspension is the important one. Rear suspension is gonna be very simple, much simpler than this. Because in the rear suspension we actually don't need multilink. There in the rear suspension we can utilize the scrub radius. We can have the largest scrub radius. There it's not important, but in the front it is, because the front is the steered part, and when we have steering, things are much more important, because this means steering means control, and if you can't properly steer the car, you have no control. Yeah, front and rear are gonna get their own motors, so it's gonna be a 50-50 split basically. So this is approximate, of course. Don't quote me on this. This is excellent. Wow, okay. This articulation is actually pretty impressive. Pretty impressive. Okay. Okay, I mean, this, of course, is gonna try to go out because it's just temporary. But yeah, I mean, okay, this is amazing. This is amazing. This actually freaking works. And the steering angles are actually pretty impressive. Holy shit. Looks like with these steering angles we don't need rear steering. Let me just fix this so I can test come on, fit in here. Okay, so I can test if we get any binding here, or how much binding we get. I need a connector. Okay, we need to limit it here. That's okay. And this limits it already. Yeah. Okay. Not bad. Not bad at all. I would say great success. Great success. Great success. Now we need to make a mount for the struts. This is just temporary, of course, so ignored. And it's this is okay. This is pretty damn okay. This makes me happy. Really happy. I mean, you can see, of course, that if we went like maybe not even half a stud back, if we moved the black link half a stud back, that would be okay. That would be okay, yeah. I mean, we do have, obviously, we do have movement here, but the important movement is if the wheel, what the wheel does. And the wheel, with the arrangement of the McPherson like this, the wheel actually does, as you can see, the wheel does have momentum. See? This happens. So that's okay, but this is allowed to happen as well. And the thing is, if I do this in the Sierra, this would happen as well. You know, this binding of the strut. But the biggest problem is in here. But this is solvable. This thing is solvable. You know, this wobbling here, and the actual binding of the strut itself is not that big. Most of the wobbling that we see here is in here, and this is solvable. Yeah, the old longer arms. Let's fit them. I think I have one. No, I don't have one assembled, but let's assemble it and see. what happens. So then we can move this a little bit forward. Maybe. No. No. They won't fit. They will hit here. So they won't fit. But yeah, the main problem here is the wobble here. In here. See, it's it the wobble in here allows most of the movement that you see here. Because the front and right movement, well, we have some of it is movement in the ball joints have slack. Some of the movement that you see is, of course, that this structure here is just temporary. It's on axles, and this is not okay. So we need to change that. But yeah, what if we have these two mounted differently? What if we have them mounted on this, just temporary, just to see what happens? Okay. So, okay, this guy is now straight, which is good. A lot less binding on everything. Should be fine. And you can also see that the sleeve of the CV is actually not going in and out as much as it did before. So it looks okay. I mean, conceptually, this is cool. This is okay. And now that we mounted this guy one stud further in, see, now this is kind of also improved a little bit. Once we made a fixed connection here, this should be fine. No, that now you have to keep in mind that this is moving. So we cannot judge this properly. But no matter what we do, there will always be slack in the, you see, slack in the ball joints. This is not our fault. That's just Lego's fault. So yeah. Let's see what left did. Yeah, that looks alright. That looks alright. That looks pretty alright, Liv. But of course, you should do what we did in the Sierra, where you have room in the middle. You want to have the structure of the car as close, so the frame rails, you want them to be as close to the wheels as possible, so that you have all the room in the middle. You want, the middle needs to be free for your engines and stuff. Okay, so let's engineer the strut mounts. So the strut mounts right now are, of course, a horrible mess. What can we do here? Ideally, of course, it would be one part, but that's impossible. Would we gain anything if we use these here? I wonder. Would we gain anything if we use these? Maybe. Maybe. So what we could do here in the front, we can use this, and this, have them being mounted like this. Okay, that would be great. Yeah, I mean, if anybody understands prototypes, it's me. I fully get the messy look of prototypes. That's just how it is. No shame in that. Okay, that's okay. And here in the rear, well, we already have a great opportunity for a mounting point, just staring us in the face like this, and the same on the other side, and we're done. Very nice, very nice, with minimal parts. Come on. Did I have a 7 stud? No, I didn't. Take a new one. Okay. This would be our strut mount. We can replace this one. Oh, yeah, okay. Yeah, of course, I forgot a few things, of course. forgot why I changed this in the first place. Bam. Yeah, this is the front. This is the front. Why would I use a double shock absorber? I don't need. We didn't need two shock absorbers in the Sierra, and the Sierra is considerably heavier than this is gonna be. So there's no need. And if you mean these, no way. There's several reasons why we don't use these. Okay, let me think. Problem is that if we now use what we did here, we are one stud further to the front than we wanna be. We wanna be here. So we wanna be here. So we have to rethink this a little bit. But we want the struts to be basically mounted here, because then that makes the most direct connection, and it's gonna be the sturdiest. So okay, that's not gonna be okay, and we have to use these two mounting points because we cannot just extend them. We can extend this one here, but not this one, because this one goes straight through this and fixes this guy in place. And if we use anything other than this, why am I talking crap? Oh god, that's so stupid. I'm so stupid. Oh. If only I would think. I'm not thinking. Of course it's possible. What am I saying? There. Now all I need is this. And here I need this. Job done. Perfect. This is now, of course, now I can't. Now I don't have to hold this, and this is already another level. So now we fix this. Now we fix this, so we can properly judge this here, and then we build a mount for this, and then we build the steering. So once we do this, we are basically where we ended up last time. Only that the structure that we're gonna end up with is gonna be like half the weight of what we had before. So all of this is gonna be so much lighter than we had before. Incredible. I mean, it sounds almost impossible, but yeah. This is gonna be so much better. Yeah. Okay. Let's build a prototype for this, so that we don't have to destroy this. Then I'm not gonna remember how it went back together because I'm old. There. Keep this. assembled. Just taking up space and parts that we might use later. Do I have another? Yeah, I do. Okay. I need this here, of course. So, and this. Now, how do we replicate this? That's gonna be a problem. Because what we want is we want a pin going through this, not an axle. And this is problematic because here there is no room for this. Not with this part, at least. So not with this part. I'm being careful with my words because there are parts that would make this perfectly possible. For example, we are like literally making a multi-link front right now. But you know, maybe you can go in Discord and post some questions, some specific questions, and I can then maybe for in the suggestion for content section, and if you post some specific questions, I maybe then can have something to go on. What's missing? What do you want to know? Where's the problem? You know, that kind of thing. Okay, so one possible part is this, but the other more likely part is going to be this. So imagine we use this part here like that, and we use a bar in here. So we have this guy going here, and then the rest is as is. There. There. Holy shit. The link to the Discord is below every stream. So if you go to an older stream, like Tuesday stream, there's links down below of all my social media stuff, and one of them is the Discord. You click on it and you get to the Discord. Shouldn't be really hard to find. Well, I'm just gonna implement this. No use, basically, there's no reason not to. Okay, basically we just change this here for this. No more wobbling. Who would have thought? Holy shit. There's something wrong. Oh yeah. Okay. I know what's wrong. There we go. Okay. And now the only wobble that we get, as far as I can see, is in the spring itself. So that's all we get. No more wobbling here. And you know, okay, that's because this is not fixed yet, but that's livable. And if I basically try to, you know, simulate the wheel hitting stuff, that's gonna be perfect. Good enough. And the steering angles are very good. We need to build, of course, the other side to properly judge if the angles of the car on the ground, so if the wheels when the car is rolling are, you know, being properly leveled with the ground. So that's something that we're gonna judge once we, you know, make the steering. But first, we need to fix this. So obviously, we need to make some sort of connection to the back as we did before. But now we have more room. Basically, we have a lot more room because only thing that's here in the suspension is the McPherson. There's no there is no link to the pull rod or anything. There's no A-arms here. Let's see what we can do. Imagine that. Imagine that. Imagine that the spring hitting this part is actually limiting the steering angle. That's new. That's new. Okay, but this means that we have to re-engineer this. Lovely. So basically, this is an integral part of the whole thing. I'm just gonna remove this to see what's happening. If we gain, yeah, we gain a lot. We actually gain a lot. Yeah. And this is still not binding. Yeah. And the steering angle is actually quite alright. See? This steering angle needs to be bigger anyway, so yeah. Yeah, this starts binding. No, it doesn't. Steering angles are perfectly acceptable, actually. Yeah. Just as the doctor ordered. Yeah. I'm holding it. Yeah. Okay. So we need to re-engineer this. Okay. I'm fine with this because essentially what we can do, which is not a bad thing, we are gonna place this here which we couldn't before. And it's gonna be just as all right. And then we have the sides free to mount whatever we need, which we hadn't have before. There. So, what we can do now, I think, we can do this, for example. Maybe not quite. Oh yeah. Oh yeah. We can do this in the front. Very interesting. So. And if we can do this in the front, we can't do it in the rear, of course, but okay. The front is saved. So we have room in the front to do the structure. This is just an example. Who doesn't like sausages? And Ben, that's a trick question. Don't answer this. I'm wondering here. We have several options now. Something like this, which I'm not a fan of. Or something like this. But I have a feeling that this is gonna hit. Yeah, that's hit. Try, Leon, try saying fish sticks very quickly. Then you'll understand. It's a very old joke. It's actually I'm disappointed in Leon in Ben that he actually made this joke. That's so childish. That's really childish. Okay. What is a shawarma? I have never heard of that. Okay, how do we deal with this? So, the problem here is, of course, we want this symmetrical, this gear. This gear here is the reason why we need things to start here. I don't know. I kinda didn't expect a joke like this here out of the blue. So yeah. So the issue here is, there's always issue, of course. The strut is getting very close to everything here, preventing us from mounting anything here. Yeah, can't be like that. So basically, yeah, yeah, basically we must go with something like this. I don't know where this leads us. Oh, damn it. Okay, even here it binds. Even with this, we have a problem. We don't have a problem like this. Okay, but this is pretty high. Pretty high to mount. A weird chassis. I don't like this. But I don't see, realistically, I don't see how we can mount anything here because the suspension is in the way. I mean, it's either the suspension or this gear. And if we want it symmetrical, we cannot have it here. Man, what the hell? Okay, I mean, this can work. This can work, maybe. Come on. Okay. I'm now just fooling around a little bit. Don't mind me. Trying to see what works, what doesn't, where the geometry here kinda is. This is not gonna stay here. It's just for experiments and thing. The problem is that, you know, whatever we put in here, this thing can bind. I don't think that in this position this suspension is gonna, you know, go way past this, but you never know. You know, you have to, in the suspension, you have to leave it space to do whatever it must do. problem is that there's no other way to get past this gear. At least from what I see. Unless we change this here. Unless we change the lower T-bone to something else. Then should be good. If we change the T-bone here and replace it we can replace the T-bone here with this guy, and we can have a this running through them, kinda, if you know what I mean. So we could potentially do this. Potentially, I don't know if this is a good idea. So potentially we could do something like this. Yeah, it's gonna clear. It's gonna clear the differential. It's gonna clear the differential. And here we're gonna use this. Come on. This. And this. So we would use this. This here provides us with a solid foundation here, so that this doesn't move left and right. The rest would be taken up, of course, by the T-bone up here. Okay, so this is still pretty solid, you know, still pretty solid. And here we would suddenly gain this part here, which should clear both gears. It should clear this one. It does. And absolutely it does clear the upper one, because the upper gear is here. It's gonna be here. Okay, so we have this suddenly, and if you imagine this in place of this, we do have this now. Very, very solid mounting stud, if you will, which we can use then to mount our, well, whatever we have to mount. And it's gonna be the mount for this here and the mount for these here. So we want basically, yeah, well, these here need to go. Yeah, these need to go entirely. We don't want these, and we certainly don't want this here. So now that when we steer, this lift arm here doesn't hit anything. Now on this side we could do something, but since we want it symmetrical and there's the gear here, we can't. We have to do it symmetrical, and yeah. Here we would have to go one stud further out, and we can't because we suddenly get this in the way that's gonna hit whatever we place here. So this sucks. We could have something here, I guess. Yeah, this would go. If we had this here, this would be possible. No. And then we're gonna have the stud connection here. That's an idea. I don't know yet how to do this, since we have to respect this guy here. So this connection. It's gonna be interesting. So if we extend this, yeah, already a problem. Already a problem. Okay, so we cannot, since the gear, the big gear is up there, we cannot place this here because it's gonna clash with the gear. We cannot place it down here because then we cannot mount the nine long links. I mean, but hey, what am I doing here? What am I thinking even? But of course, why don't we do it like this? Now we can do this. Or can we? Wait. That's too good to be true. No, we can't. We can't because reasons. Now, since this is the same height as our links would need to be, that's not gonna go. No, that's not gonna go. I mean, I'm really struggling to think of what to do here. I'm thinking, would this be possible? What if I do something like this? Will this clear the gear or not? I think not. Yeah, it's not. clear the gear. Damn it. But if we somehow manage to extend it by one stud, then it would. But at the same time, I would like it to be, well, kinda sturdy. You know? I would like it to be kinda sturdy. We might have a piece. This is a long shot. A long shot. Okay. So many things in the way. So many things in the way, because now that we want to incorporate this, right? Somehow. And we want to kinda, if we take this as an example, we need to okay. This is possible. Blimey. This is possible. This is possible. Okay. Okay. This is possible. Let's see. Let's see. I mean, we are complicating something that should be very simple, but that's us. That's us. I don't like the axle on pin connection, but we are probably gonna have to live with it because this is a structural part. And structural parts should not have an axle on pin connection. Axle and pinhole connection, sorry. And yeah, we are good. We are good, and everything else clears. Okay. Here, of course, we need a different kind of pin. Need this here. Because this holds the differential. the differential carrier is held by these. But okay, this is, keep in mind, this, we are building a race car, and yeah, this is sturdy enough. We are building a race car, and race cars do tend to have solutions that are sometimes a little unorthodox, let's say. So this thing here, and we're gonna build the complete assembly, of course, because we're gonna change this. Once we've done this, we're gonna, swap it out immediately. So yeah, I hope that this is clearing the struts, but yeah, what we have here is we are basically looking at the back part here. Okay. So that's why I'm not sure about this, but I think, yeah, this should clear. Should clear. Yeah, because this connector here takes the place of this. So the connector here, this guy is basically this. And this clears. Okay. I'm not sure though about this here. Yeah, it hits it, which is a bummer. Actually, quite a big bummer. Because then we don't have a good way to mount the diff carrier. Unless we turn the diff carrier 90 degrees and we mount it from the top, where the T-bone has to pin in anyway, and we brace it on the bottom with something. That would then be okay. So we could do the following. We could, turn this 90 degree, and then we have it pinned from the top, and we brace it on the bottom. We can brace it on the bottom, of course, by just putting some pins in it. And yeah, here we cannot do anything. And here we cannot do anything, but we can. Oh, come on. Yeah, here it is. Exactly. That's what I wanted to do. We do this. Now, this here is not gonna be a problem because the central gear is gonna be braced together with this gear here anyway, and it cannot go on the other side because on the other side is the diff already, and it should be perfectly fine. So we can omit this. We can change this back to this. And have this. These, of course, are temporary. Maybe they are going to be used for something. Maybe they are just here for, just being here. So this has room. These are just placeholders now, so don't worry about it. This has room, and this has room. So very nice. And of course, we are bracing those two with this. So yeah. Now we have this here, which we can use to extend, or basically to do anything with what we have here. I mean, it sounds weird, but basically what we can do here is this. See? These two guys here are our continuation of this, because there's absolutely no other way to use anything here. We cannot use these here. We can use these holes here, of course, but I would rather not use them for structural stuff because I want this removable. This is now nicely fixed. That's okay. Yeah, this is really sturdy, so that's great. Yeah. Now these two need to be braced by something, I guess. We literally don't have room to do this because here, you know, here is gonna be the 9 stud link, so we cannot extend those one stud down. Literally, this is the only connection we can have here. Wow. That's quite extreme, but okay. I mean, we've been through worse. We've been through worse, and yeah, this solves a few things and cleans this up a little bit. Yeah, so that's all right. Sorry. So this is okay. And I wonder where our steering rack is gonna sit, and we probably should use come on, really. Lego bricks sticking to my arm. We should use the axle hose here to our advantage to make this a one piece, and then we need to use somehow these two to make a frame here, a rigid frame, to which then the rest of the body is gonna connect somehow. I am not sure about this because, see, this is gonna happen. I'm not very comfortable with this. Not absolutely do not want to burden this with anything, because this is not meant to be a structural element. It's just a bracing for this. I mean, we are gonna have these here, of course. Which we could utilize for something, but then we don't have a removable brace here. You know, we could use these to aid us in our struggle. For example, like this. But I am afraid that probably we have a steering rack going through here. Or something, you know. This would be okay. We, of course, this wouldn't be a axle connection, but a pin connection, but you know, just for demonstration. This could be an option. I mean, yeah, I could live with that. Could live with that. And this, yeah, this would yeah, and flexing this doesn't even affect this that much. Yeah, and we would have an axle. Yeah, we could have. Okay, yeah. Then this would flex even less. So we can have a. Oh, come on. Whoops. Okay, it went out of this universe. All right. I'm never gonna find it again. So we can have this here. And then, you know, whatever we have here. Okay, yeah. This is very strong. Okay, yeah, we can have this connection here. And you know, once this is fixed on the other side, this is gonna be even stronger, you know, because now we have some movement, then we won't. So yeah, this is gonna be insanely strong. And I don't think that we are gonna ever break those two gears. If anything, this guy is gonna break. Yeah. And we need a 7 stud here anyway. And this guy needs to be a 4 stud. Preferably this. Like that. Yeah. Okay. So we have established a few things. Let's integrate this into what we have. Okay, the trickiest part is getting this apart, of course, because everything has to come apart and things are gonna fall out. Or are they? No, they're not. Okay, yeah, gonna be easier than I thought. Okay, this has to come out in any case. Yeah, it has to come out. Because reasons. Yeah, this is the reason. See, this is exactly why I don't like Lego stuff. The stuff produced by the Lego company. Because if you want to change anything, you have to take apart everything. And I don't like this philosophy. But it is what it is. Luckily, it's not that difficult here. There. Now we need to figure out what you're gonna do here. It's not gonna be the same as on the other side, of course. We can do something here, or can we, to support this guy? No, we don't have to. Of course, this guy is mounted on the side. Okay, yeah, it is mounted on the side, and here we basically nothing. We just put an axle through, and that's it. That's all that we do. All super complicated to build. I'm gonna hate myself if I have to. No, sorry. When I'm gonna have to take this apart again. The red gear or not? The differential casing. The differential casing has a clutch connection on the other side. The gear doesn't. Of course. Everything is so integrated and particular. Okay, come on. Yeah. No, because we need this here. There. For this. Okay, so I don't like this connection here, so we have to change it. See, this is happening, and the problem is with this that I'm now gonna slap this. I'm gonna slap this on it. Like that. Not a problem in itself, of course, because I can use these two. But this is kind of not what I want. This kind of movement. So what do we do here? I think if we put a one of those connectors in here, we might get better results. Come on. I hear Discord. Yeah, I hear Discord. Just a second. Just a second. Let me open up Discord. Wow, oh my god, you guys have written a lot of stuff. Okay. Oh my god, JSP. Just don't start trolling. It's gonna be an insta ban. Okay, that's gonna be some suffering getting this in. Oh man. Oh, okay. That was easier than expected. Okay. Let's see. Oh yeah. That's much better. What's missing is this. There. And there. Okay. Again, I don't know if we are gonna use this exactly, but just to have something there. So almost there. Imagine, almost there. There we go. Holy shit. And this is actually, it's not as good as it was, I have to admit. The casing here was a lot stronger when these guys here were on the side. Because obvious reasons, but they can't be. Three X5 lift arms. Where? Where are you gonna use 3x5 lift arms? I would use them instead of this here. Unfortunately, this would hit. But if I had something that I could replace this with. Like a 4-stud thingy. 4x2 lift arms are not okay. But the 3x5 would hit this, so we can't use them here, unfortunately. What could we use here? We could have something once, so we could have something one step further up, like for example we could have this here, but I think, yeah, we can't utilize those two holes here. We could utilize just this one. Ideally, we would have this guy here, a 4 times 5 would be okay. Yeah, 4 times 5 would be okay. But we don't. We don't. And this would perfectly combine this together. Because you see, then this wouldn't hit. And here we have the room. So little room. This is getting pretty good. Pretty good. These, of course, are going to be replaced with something here. There are just placeholders because I don't know what we're going to do here. And of course, I don't know what the right height is going to be. Final right height. I don't know. Maybe this is going to be the top of the hood. And it's going to be fine. Yeah. Anyway. Yeah. We are gonna end the stream here because I'm getting tired. But that's it. We are in the game. There are, of course, issues that we have to address. Not huge issues, of course, but you know, nevertheless, the whole structure is less intense than it was before, and it's lighter. It's simply lighter. This is gonna be just a lighter car. with this. And the McPherson is just, you know, it's just gonna take the beating. And we have springs. If we didn't do the McPherson, there would be literally no way for us to mount the springs. 1,000 with a 2 times 1/3. Yeah, and then what? What would you do then? We are not gonna gain anything interesting from this. Yes, I can mount this to this then, but yeah, true. That's okay. Yeah, I haven't thought about that. That's true. Okay, so we can have this, and then we can have a 1x3. Let's see if this helps. And if we have clearance. Yeah, we do have clearance. But you know what? Once we're here, we can right away use this. No, we must use this, like this. I don't know where this is gonna help us, but you know, we're using it here. Yeah, this is much better. This is much better. Come on. Need to replace the X in here. This is just an idea what we can that we can, or a reminder that we can use this. We can use something else entirely, but we could use, you know, the T-piece, but we can use it if we want to. Maybe for bodywork or something. There. Well, you have to remember something first. This is the length is how the car is going to be when the shocks are fully extended. The right height is going to be something like this, and then when the shocks are fully compressed, it's going to be, well, compressed more, you know. So this is at when the car is jumping, this is going to be this, and then when it lands, it's going to be, you know, something like this. And as I said before, we are going to hide, if necessary, we're going to hide the shocks as a hood bulge. So it's gonna be a hood bulge, power bulge, or whatever. But since the wheels are, the wheels are here, this is already kind of windshield area sorts. We can hide it, no problem. The hood can be in this level, and then we just have a step up for, I don't know, something. So it's not gonna be a problem, and the sides are gonna be fine. We're gonna just have a hump here if necessary, you know so yeah, that's it. Till the next stream, of course. So over the weekend, things are gonna progress, of course, because I am pretty certain that Ben, Christian, or someone else is gonna have some suggestions. Always welcome. And I'm absolutely gonna build the other side, so we can have this symmetrical. Yeah, this is pretty good. Pretty good. Not, I mean, it's not worse than it was when we had the double wishbone. But yeah, this is absolutely fantastic. I love it. I'm such a fan of McPherson suspensions. This is gonna be great. Just as it should be, as the Germans intended. The rear axle is gonna be a lot simpler, because in the rear axle we don't have to have we don't have steering, or we probably won't have steering. We will have probably a McPherson like here, but the lower wishbone is not gonna allow steering. So it's gonna be just a fixed connection. So it's gonna be really simple, a lot simpler than this. Since the real car, so the real Audi, also had something similar. They also did not have steering in the rear, so but it was basically a mirrored front suspension. So we're gonna have a similar situation than here, only without the steering, which will make it a lot simpler, because we won't have this here. See, we won't have these steering arms. We are gonna just have probably just connections to this here with these here, and that's gonna be it. Nothing more. Probably not, because you see, these angles are actually pretty good, and I don't think we are gonna need them. I don't think, but if we do, we can still reconfigure the rear a little bit. It's still possible. But I want to keep it as simple as possible. Simply, so we have to have steering here. That's the thing. In the rear we don't. So we are gonna keep it as simple as possible. So all of these problems that we have here with the connections and stuff that are not gonna exist in the rear, because the strut is not moving. It's the strut is static. So the clearance that you see here is the clearance that you get. So you can have a continuous structure here without worrying too much. We don't have to have this problem here. So it's gonna be a lot simpler than this. McPherson, it's gonna stay McPherson, because that's true to the original, and it's simple, of course, but it's gonna be a lot simpler than this. This is only complicated because of steering. If there wasn't steering, it would be really not complicated. But yeah, that's it for today. Next stream is on Monday. Do join us on Discord, of course. And have a nice weekend.